Hey guys, welcome to chemistry. This is your first chemistry lesson. So what I want you to do is split your screen so that you have my video lesson on the left and your student notes on the right. Your student notes are interactive, so you want to be able to click on the links that are provided and you'll be able to write in your responses on your student notes. Also, if you look at the click here column, you can click on any of these tabs and that's going to take you to a certain page in this slideshow. So let's begin. Click on What is Chemistry? What is chemistry? In this section, you're going to determine how chemistry is related to matter. Let me show you a little demonstration. So again, as I'm doing this demonstration, I want you to think about what is chemistry? Let's watch. Pause this video and come back when you're done watching. Welcome back. So what did you learn? Chemistry is a branch of science that involves matter and how it changes, as you saw in that demonstration. It's the study of the physical world around you. Chemical reactions are occurring all around you. You might not even think about the ones that are occurring in your body or in the air. I want you to think of some concrete examples right now and fill them in this thought bubble on your student notes. Okay, for the next thing I want you to think about is what kinds of chemical reactions are occurring in this photo here. This is a photo of a house in the woods. After you list 2 or 3 of the chemical reactions you see occurring, provide me with some evidence that you know of to prove your assumption. Okay, so I want what chemical reactions you think are occurring and some evidence that you can see in this photo that tells you a chemical reaction is occurring. So if chemistry is the study of matter and how it changes, what is matter? Matter is everything in the universe around you, whether you see it or not. It has a definite composition. We can also refer to this as a substance. The amount of matter that makes up a substance is its mass. So substances are made up of atoms, and each atom has a certain mass, which is a physical property that each element has. Now, mass is different from weight. You may have heard in everyday conversation the term weight used in place of mass, especially in the science room, but they are completely different properties. So mass is the amount of matter that makes up an object, whereas weight is the pull on that matter. So your weight would be your body's mass, such as a 52 kilogram person, times the acceleration of gravity, which is 9.8 meters per second squared, which gives you a weight of 510 newtons. Now you can convert that to pounds, but we won't do that here. Okay, so another difference between mass and weight. Why does chemistry matter in today's day and age? Well, it's 2020 and we're all wearing masks due to COVID-19, and the chemists are hard at work looking for that vaccine. In high school, you might take chemistry because you want to be a medical doctor, a nurse, a veterinarian. I've had a couple students go to veterinary school in the past. I've had a couple pediatricians, pharmacists, and one of my students wanted to become a biomedical engineer. Hey guys, welcome back. This section is on defining matter. Split your screen so that you have my video on one side and your student notes on the other. In this section, you're going to identify characteristics of a substance, distinguish between physical and chemical properties, differentiate among physical states of matter, differentiate between physical and chemical changes, and list examples of each, and then determine how matter is defined. Think about this. How can matter be broken down into atoms? Write a response for me, and when you're done, come on back. For this section, I want you to fold a sheet of paper into 4 sections and label each box physical properties, physical changes, and chemical changes. You're going to take some notes in each corner of that paper and write down some examples as we go through the following lesson. And also you'll find some answers in the videos that I show you. Now I love 90s videos. They just have, I don't know, some kind of nostalgic value for me, but my students get a kick out of them. So you'll see what I mean. These little video clips, they're awesome. Very educational, I can say that.
Anything that takes up space and has weight is matter. But is everything we see or hear around us matter? Is a shadow matter?
No, a shadow does not take up space. I saw a rock.
Is a whisper matter?
No, a whisper doesn't take up space.
Is a tree matter?
Yes!
Why are color, volume, and density classified as physical properties? What is a physical property? Well, it's something that can be observed and measured. Take a look at your pencil, for example. What you can see and what you can measure about your pencil are the physical properties of that pencil. Other examples include shape, color, odor, texture, melting point, and boiling point. Strength, hardness, conductivity, magnetism, specific heat, density. Boiling point, freezing point. These are some things to note about water. They're good reference points so that when we talk about other chemicals, you have something to compare to. The boiling point of water is 100 degrees Celsius and the freezing point is 0 degrees Celsius. On the Fahrenheit scale, that would be 212 degrees Fahrenheit. And what is it for freezing? That's correct. It is 32 degrees Fahrenheit. Now, why are these properties important? They tell us how we can use these elements or compounds. Aluminum is used in foil because it's lightweight, yet it's durable and it's flexible. Durable means to withstand damage or wear. So it holds up over time. Flexible means bending without breaking. Now, we don't use aluminum for things that have to be very rigid. In that case, we might use a product like steel. Steel is used in cars because it is strong and it provides structure. Yes, there is some aluminum used in cars, but the main frame is going to be steel, and that's going to help protect you a little bit in a car crash, for example. Let's do a launch lab. I want you to obtain 4 different liquids. If you're at home, you can grab 4 from your kitchen, and if you're in the classroom, I'll provide you with some. I'm going to use water, add some food coloring to it just to make it more visible, corn syrup, rubbing alcohol, and vegetable oil. You can dye the rubbing alcohol as well. You can use any 4 liquids that you have in your kitchen, though. Don't use toxic cleaners like bleach or Windex or anything like that. Just some food grade stuff. Corn syrup, vegetable oil. Most people have those in their house. Anyway, I want you to obtain a clear glass or a graduated cylinder, and you're going to pour about 5 milliliters of each of these liquids into your cylinder and watch what happens. You're going to tilt the graduated cylinder or glass and slowly pour the liquid so that it runs down the inside. When adding the glycerol, which I don't have, allow it to settle before adding the next liquid. So you want to try not to disturb the liquids when you stack them. Did the liquids form 4 distinct layers? If they did not, rinse out the graduated cylinder and repeat these steps again using a different order. I want you to answer these few questions here. Just create a text box and you can type them in or you can write them in your science notebook. Number 1 says identify the order from top to bottom of the layers in the graduated cylinder. And 2, hypothesize what property of the liquids is responsible for the arrangement of the layers. What do you think would happen if you dropped pieces of metal like a paper clip, plastic, maybe a pencil eraser, and wood, maybe a piece of pencil? were added to the layers of liquid in the cylinder. Where do you think those would fall? Which liquids would they fall below and which liquids would they float on top of? If you have some of those objects, go ahead and try it. Let me know what you discovered. So that's 1, 2, and the inquiry question. Let's move on to chemical properties. Chemical properties tell you how a substance reacts with others to form new substances, and it's going to help a scientist to classify a substance. For example, sodium, it reacts easily with other elements, so it's classified as highly reactive. Gold does not like to react, and it's usually found alone, meaning you won't find gold compounds usually, unless it's man-made. So gold makes really nice jewelry. It doesn't tarnish, and tarnish is a chemical reaction. Argon does not react. It is the gas that is found in light bulbs. Keep in mind, reactivity is the capability of a substance to combine with other substances. Iron rusts, carbon is flammable, like charcoal in a grill. Think about this. Which reacts more easily with oxygen? Iron, paint, or chromium? Take a look at this image. Which one do you think it is? That's right, it is iron. When iron combines with oxygen, you get iron oxide, which is known as rust. So once the paint wears off of a car, it exposes the iron or steel underneath, and when that is exposed to oxygen, it rusts. And usually the car has to get wet, like it has to get rained on, because there is oxygen in water, and that direct contact, the way that the water adheres to the metal, causes it to rust quickly. Physical changes are changes that occur without changing the chemical makeup of a substance. So in other words, the atoms are not changed or rearranged. The compounds remain the same compounds. If you get your hair cut, that's an example of a physical change. You're cutting the hair into smaller pieces, but you're not changing the chemical makeup of the hair itself. Grinding peanuts into peanut butter. You're making the pieces smaller, but again, not changing the chemical makeup. Pounding gold nuggets into rings, dissolving, cutting, crushing, etc., melting. All of these are physical changes. Watch this video to find out more. Enjoy!
What changes occur when this ice cube is crushed with these pliers? As you can see, the ice breaks into many small pieces of ice. This is a block of clay. It is soft and can be shaped into something different, like this turtle. And these chopsticks, used to eat food, were shaped from trees like these. All these materials have gone through a change, a physical change. A physical change is a change in the size, shape, or phase of matter without the matter changing chemically. Let's look at some more examples of physical changes. When relatively cold, the water in these icicles is frozen rock solid. But as the temperature warms, the ice gradually changes to a liquid, forming these liquid drops of water. The water changed phase from a solid to a liquid, but still remains water. Temperature can play a big role in physical changes. Temperature can also affect the size of objects. For example, this metal lid expands when exposed to hot water, thus making it easier to loosen. And this bicycle tire contracts or gets smaller when the temperature decreases. This can be seen easily in a thermometer. When the temperature increases, it causes the liquid in the thermometer to expand and then rise. But when placed in ice water, the red liquid contracts and then drops. Another example of a physical change involves water. Water at room temperature is a liquid. When the water is placed outdoors on a cold winter day where the temperature is below 0 degrees centigrade, it changes to its solid phase, or ice. And if the water were to change to steam or gas, it changes its phase, but still exists as water. In a physical change, matter can also change its shape. For example, these branches are long and thick, but when placed in this chipper, they get ground into small pieces of wood. The wood chips come from the wooden branches that were changed physically into smaller pieces of wood. Their shape has been changed. We have studied some examples of physical changes, including changes in size, phase, and shape. Now let's explore other changes in matter, chemical changes.
Now let's take a look at chemical changes. A chemical change occurs when a substance changes composition by forming a new substance. So the atoms that make up the substance have been rearranged into new compounds. Examples include when you burn anything. Let's say you burn a sheet of paper and it turns into ash. You cannot take that ash and turn it back into paper. Thus, you know that a chemical change has occurred. So whenever you change a substance into something new and it cannot be changed back, for the most part, that is a chemical change. When a battery dies and is not rechargeable, the chemicals inside have changed. During respiration, you take in oxygen from the air and water and whatever else is in the air, and you breathe out carbon dioxide, water, vapor, etc. That is a chemical change. It's a chemical reaction that occurs in the lungs. Mixing vinegar and baking soda is popular among students. If you've ever made a volcano, this is probably something that you've used. And when they react, they form a gas, carbon dioxide, and salt water, NaCl. When leaves change color in the fall, that is a chemical change. Let me show you a short clip. Enjoy.
In physical changes, you have the same material before and after the change. For example, with paper, we have a large piece of paper that can be torn into many small pieces, a physical change. Even though the appearance of the paper has changed, it is still paper. This is a physical change. In other words, the chemical properties of the paper have not changed. A chemical property is the way to describe how matter reacts with other matter. The paper we have just torn up, for example, can burn easily if we light it with the match. The ability to burn is described by the chemical property called flammability. The paper went through a chemical change. How do we know this? One way we know that a chemical change is occurring is that we can see it. Before the change, the paper looked white, but after the change, it was black. Another clue that a chemical change occurred is that heat is given off. We can feel the warmth from the burning paper. To make absolutely sure that a chemical change occurred, we could study the chemical makeup of the paper in a laboratory using special equipment before and after the reaction. This would show that the white paper has a different chemistry from the ashes after burning it. A chemical change is defined as the process by which a certain substance becomes a different substance. Let's take a look at another chemical change. This is a chemical called iodine. We will put a few drops of it on this piece of potato. Notice the color change. The potato has something in it called starch, which creates a chemical reaction with the iodine. We can see the results of the chemical reaction by the color change. Here are some points that determine if a chemical change has occurred. In chemical changes, a new substance is formed. In chemical changes such as the cooking of this egg, a color change occurs on the outside of the egg from clear to white. Sometimes in chemical changes, as in the case of the burning flare, heat and/or light is given off. And in some chemical changes, such as when this tablet is placed in water, bubbles form, which is another clue that a chemical reaction may have occurred.
So what is matter? Matter is a substance defined by physical and chemical properties, and also by how the substances can be separated. On the back of your 4-square paper, I want you to take some notes on how separating mixtures is different from separating compounds, okay? So now you're going to learn the difference between a mixture and a compound. Let's start up here at the top. And this, you can take up like half a page here. Let's start with the atom. The atom is the basic unit of matter. Now it can be broken down into smaller particles like subatomic particles, including electrons, neutrons, and protons. Electron has a negative charge, a proton has a positive charge, and a neutron is neutral, 0 charge. These atoms are different, and their differences tell you which element they are. So an atom of hydrogen has 1 proton, where an atom of oxygen has 8. These elements combine. They can combine using different elements, such as when hydrogen and oxygen combine in a 2-to-1 ratio, you get the compound H2O, or water. When oxygen and carbon combine in a 2-to-1 ratio, you get CO2, or carbon dioxide. So these are compounds because they're made up of different elements. Now these elements can combine together as the same elements. So if 2 atoms of hydrogen join together, you get a molecule, not a compound because it doesn't involve different elements. But this molecule is hydrogen gas, H2. Oxygen joins together with itself to form O2. And what about this one here? This is H2O. This is a compound. Now, all compounds are molecules. So molecules can include the same element bonded together or different elements bonded together. But not all molecules are compounds because hydrogen gas and oxygen gas are not compounds. Does that make sense? They don't have more than one element that makes them up. So copy this into your notes. Chemists will classify matter based on whether it is a pure substance or a mixture. Now, pure substances can be further classified into elements just themselves, like hydrogen or oxygen, or they can be classified as compounds when they're joined together, like water or carbon dioxide. Matter that is a mixture can be further classified into a homogeneous mixture or a heterogeneous mixture. Homo is Latin meaning same. So if the mixture looks the same throughout, it is homogeneous. If the mixture looks different throughout, it is considered heterogeneous. Like the toppings on a pizza, you can see the pepperoni, you can see the mushrooms, you can see the green olives. It'll be a heterogeneous mixture. Same with a salad. Homogeneous would be like a Jell-O cup. You can't see the tiny little particles of gelatin that are suspended in it. So it's homogeneous. It looks the same throughout. It looks smooth. Homogeneous mixtures can be made up of 2 miscible liquids, like water and rubbing alcohol. You can mix them together and they blend pretty nicely. And a heterogeneous mixture of 2 liquids, they would be considered immiscible liquids, like water and vegetable oil. They form distinct layers. Even if you shake them up and try and stir them together, after a few hours, they're going to form distinct layers again. They're immiscible, and that's because of their properties. So how do you separate a mixture? I mean, how would you separate water and oil? How would you separate water and rubbing alcohol? Especially since it looks the same throughout. It's like you can't even take a spoon and scoop out the rubbing alcohol, for example. You wouldn't do that. So chemists have very developed certain techniques for separating mixtures. A mixture can be separated by physical changes, but compounds have to be broken down by chemical changes. So to separate a mixture, you can physically remove the parts. You can evaporate. So if you have water and rubbing alcohol and you let it sit out, the rubbing alcohol will evaporate and you'll be left with a lower volume in your glass, and that'll be the remaining water. Boiling or distillation. You can heat up your solution of water and alcohol on the stove in a pot, and the alcohol is going to boil out before the water does. So you won't see the water boiling, but at a low temperature, the alcohol will come out. And then once the water starts to boil, that would be the water transforming from a liquid to a gas. Also, centrifugation. When you have blood drawn, they can run it through a centrifuge and separate it to see the serum volume. Now, compounds, on the other hand, like C6H12O6, glucose, sugar, they have to be broken down by chemical means or by heating, by electric currents, or through chemical reactions. So you can heat and burn sugar, and it's going to break down into carbon dioxide and water vapor and leave you with carbon. I'm going to give you a small cup full of different particles, particle-sized objects, and I want you and your team to decide how you're going to separate that mixture of 3 substances. Discuss with your team how you're going to do it, and you can ask me questions about the properties of these substances to see if your method of separating the mixture would work. A mixture is a substance that can be separated by physical means. In each cup, you have glass beads, iron filings, and salt. I want you to tell me how you would separate this mixture into its components by physical means. You can tell me what tools you would use based on what you know about the properties of these 3 substances. Checkpoint! Most substances can undergo both chemical and physical changes. Which of the following statements relates to one way water undergoes a chemical change? I'm not going to read the other 2 to you. You can read. Go ahead and circle these 3 on your notes, and then we'll check. And pause this video and come back when you're done. Pause it now. Welcome back. Let's see how you did. In order for water to undergo a chemical change, it has to react. So a reaction occurs, and in this case, it's going to react with sodium to form hydrogen gas and sodium hydroxide. These are 2 new products that are produced, and you can't transform them back to water very easily. Number 2, rust. What type of change does this illustrate? If you chose chemical, you are correct. So iron Fe combines with oxygen to form iron oxide Fe2O3. And on number 3, which of these best describes this change? It is a physical change. If you picked a chemical change, it's not chemical change because you can change it back. So it is a physical change. You're just separating a mixture. So seawater is a mixture of salt and water. They're not chemically combined. They are not a compound. So salt water is not a compound. Salt water is a mixture. That's the important thing to note from that.